So it's my pleasure to give you an overview of the features that we have developed at Sanofi over the past 2 years and which are now available in this new 1.2 release of tranSMART. So my time being limited, I will focus my presentation and demo on the major announcements only, which should be of highest interest for you, I hope. So I will first present a few slides just to introduce those announcements, even if UK already gave some words about it previously. So one first major announcement we did is related to a new tab called Browse. So searching for particular studies or data sets in the former Dataset Explorer was not an easy task. So to overcome this gap, we have developed this new Browse tab where all studies and data sets which are contained in tranSMART are listed and described. At the same time, the former Dataset Explorer tab was renamed to Analyzed. We have also added some searching and browsing and filtering capabilities in order to really provide our scientists with powerful searching capabilities into tranSMART. So just after this quick overview, I will do a demo of this new Browse tab, which is actually the new homepage of tranSMART 1.2 release, where one can navigate within programs, studies, and data sets which are available into tranSMART. And from there, also users are able to search for data using specific dictionaries that have been implemented. So those two tabs, Browse and Analyzed, are synchronized to a certain extent, I would say. So in particular, they share a common search functionality that I will demo just after. So I will skip this slide to keep sufficient time for the demo, but this slide is just to tell you that we have implemented a new data organization model in order to structure our data and make sure that data sets are more easily searchable by our scientists. So this new data model is based on the ISA standard. So hopefully the demo will help you to better understand the different concepts that are shown on this slide. So new high-dimensional data types are now supported in tranSMART. This was also a major request from our scientists. Until now, only gene expression, copy number variation, and genotyping data were supported in the former release. So now tranSMART supports new omics data types such as microRNA sequencing, mRNA sequencing, qPCR, microRNA, proteomics, so both mass spec proteomics and RBM, as well as mass spec metabolomics. So those new data types can be, of course, loaded, but also analyzed through the advanced workflow, the legacy advanced workflow from the former GPL release, and can be exported outside of tranSMART using the data export tool. So I will also do a quick demo of this just after. So one very last slide to introduce the developments we made to better support what we call serial data. So serial data means data which come in series, such as time courses, dose responses, different sampling conditions, and so on. So those serial data are now better handled by tranSMART. For example, each node of serial data, whatever low-dimensional or high-dimensional, can now be associated to a numerical value, for example, a duration value in a time series. We have also enhanced the line graph workflow. And as I will show you just after, the line graph can now display serial data with a scaled x-axis. We have also enhanced some other analyses than line graph. For example, all the heat map related analyses. So those analyses now support high-dimensional serial data. So user can drag and drop several nodes of serial high-dimensional data under the variable selection box. Now it's time for the demo. So I will switch to the 1.2 test instance. So there are limited data available right now, but hopefully it will be sufficient to make this demo clear and interesting to you. So once user log into tranSMART, the home page that shows up is this new browse tab I was talking about just before. So from this browse tab, users can navigate within the data sets that are contained within tranSMART. So in order to organize this data in an optimal way, we have defined a new data organization model which contains different components, so within a hierarchical structure. So the top level component within this hierarchy is our programs. So you have two examples of programs here on the screen. So the purpose of the program is to group related studies together. So most of the time the program is defined by a molecular target, but it may also be a disease or a pathway. So from this Program Explorer window, user will be able to navigate within programs and the different components underneath the program. So to get information about a particular program, I just have to on the program name. So clicking on the program name will display a program description page with the tags associated to this program. So every program created in tranSMART is tagged based on metadata and control vocabulary, and all those tags can be used then with a search tool to search for this program. At the bottom of the program description page, I can see the components underneath the program, so which are the studies. In this particular example, there is one study belonging to this program. This is a GEO study. To display the study, I can also click on the plus icon in front of the program name, and you can see the study here. So clicking on the study name will display the study description page. So as you can see, there are more tags associated to studies than for a program. All those tags are also searchable through search and filtering features. And at the bottom, I can see what are the objects belonging to this study. And in this particular case, this GEO study, we have one assay and gene expression microarray that I can also show by clicking on the plus icon here. So clicking on the assay name will display the assay description page with the different tags associated to this assay. So every level in this hierarchy of program study assay has its own set of tags, as you can see. The lowest level in this data model here are folders. Folders are containers for files. This was also a strong request from our scientists to be able to import, search, and retrieve directly from tranSMART UI any kind of files or documents that are of interest for them. So in this particular example, within this folder, we have a set of text files containing some gene expression process data available for this student. And what we have developed is a set of functionalities here which allow users to export quite easily those files. To do so, you just have to click on Add to Export next to the file name. And here at the bottom of the screen, you can see this Export Card button. And by clicking on this Export Card button, so this export file window will show up. And from there, user can just retrieve the exported file he has selected just previously. I will now show you how to search for data set of interest. Because you can imagine that here we can have a long list of programs, studies, assay, and so on. And user may want, of course, to limit the number of data sets that you can see here under Program Explorer. So to restrict here the data display on screen, we have created a new search capabilities, which are available from the top level here of the screen. This search tool is available in both the Browse and the Analyze tab, as I will show you just after. So it includes a set of dictionaries, so search criteria based on dictionaries, but it also relies on a set of filters. So just to give you an example, user may want to see only the studies which are tagged with the study phase 2, so to get a view of which are the studies I can select this phase 2 filter. I may want also to restrict my search to study belonging to program on cancer. I can select several values for the same filter. For example, I may want also to see program belonging to this particular nutritional and metabolic disease domain. As you can see, we have a Boolean operator, so I can switch from AND to OR. You can add as many search filters and criteria as you want. You can also delete very quickly one filter by clicking the cross icon. We have some also dictionary-based search, as I said. For example, if I want to know which assays are available with data on the ERBB2 gene, for example, I can do that. So I just have to enter a string here in this search space, and as you can see, we have an autocomplete feature enabled as well as a synonym recognition. Once I have selected the particular gene of interest, okay, I see that the search returns one particular assay in bold, and this assay indeed has been tagged with this particular gene. So as I said during the introduction, this new Browse tab and the Analyze tab, which is the former Dataset Explorer, are synchronized to some extent. In particular, when I select search criteria and filter in Browse, the same search criteria applied in the Analyze tab. So if I click now on Analyze, you can see here that the same search criteria filters applied, and the study which match those criteria shows up. So we have only one particular study matching those criteria. So just before pursuing my demo in Analyze, I would like to come back in the Browse tab only 1 second to show you one very last thing to illustrate further how Browse and Analyze are synchronized. When clicking on a study name, for example, this particular study, I can see whether there are subject-level data available for this study. So thanks to this indication, I know that for this particular study, GEO study, I have some data sets, so likely clinical endpoints and gene expression data loaded within tranSMART and available for further analysis. So I just have to click on this hyperlink, open in Analyze View, and tranSMART will bring me directly under Analyze. So I am now under Analyze, and the study of interest I was looking at in Browse is here. And to display the different data nodes available for the study, I just have to click on the plus icon. So that's it for the quick demonstration of the Browse tab. Now I would like to show you some announcements we did under Analyze, so the former Dataset Explorer tab. So as we said already, there are new omics data types which are now supported and which can be analyzed in this 1.2 release. So I will just show you one example with RBM data. So I have a test, RBM test data set available in tranSMART, and I will run very quickly a hierarchical clustering analysis on RBM data. So to do so, I will build two cohorts based on patient gender, so female versus male. I will select my hierarchical clustering. I will drag and drop the RBM data node as variable. I won't select. Okay, the application is pretty slow. Okay, here it is. Click on Run, and I will get a heat map showing the different analyte concentrations. Here it is. So to get a better display of the heat map, I can click on the image, on the heat map, and the heat map will show up in an additional window where I can zoom in and zoom out using my mouse. So this makes heat map more readable. And at the top of the heat map, we have the color key. So this is only one example of a legacy advanced workflow which has been adapted to the new omics data types which are now supported. But I could also do heat maps and so on, but I won't because of time constraints. In order to illustrate the announcement we have made to support serial data, I would like to just to show you very briefly how we can now generate a line graph on serial low-dimensional data. So I have one example of a test study. So it's a clinical studies which includes glucose measures at different time points. So I select the line graph analysis. As under the time and measurement concept, I will drag and drop my the node containing the different glucose measured. Here it is. So as you can see, the different time points are listed. If I want, I can delete any of those time points just by right-clicking and clicking delete. Under the group concept, I will drag and drop the different arms of this study, which includes 3 arms. And then I click Run. So here is the heat map. As you can see here, the data points are now on scale. The day 7 and day 21 are far apart. If I want, I can also select an option to generate a plot which is evenly spaced. I can also, if I want, get a plot, one plot per subject. So there are some additional options that have been developed here on the line graph to better support serial data and longitudinal studies. But I will stop here for today. The last thing I would like to mention on serial data is that in addition to the line graph, we have also done some modification of all the heat map related analysis. So now we can drag and drop several nodes of high dimensional data under the variable selection box. So if time permits, I would like to show you very briefly some announcements we have made in the grid view. So to do so, I will select and use the same study as just before. So this was also a strong request from our scientists to be able to display in the grid view the sample ID. So as you can see now, we have a column for sample ID. We can also drag and drop categorical variables under one column. For example, I can just drag and drop the trial arms folder here. And here it is. So all different trial arms values are displayed within one column. I can only drag and drop one categorical variable if I want. I can also hide one column. And last but not least, we have added an export to Excel option here, so which allow me to export either the entire grid view or part of the grid view on any selected line. One very last announcement is related to the data export tool. All the new omics data types that are now supported can be exported. So, for example, if I drag and drop this studies and then click Data Export, the system shows me now what are the different data types that are available for this particular study and which can be exported. So I can decide to export only microRNA data or mRNA sequencing data. So you have an indication of the data type available, and you can decide to export only parts of them. In addition, we have developed a new functionality to select only a particular data node for export. So if I want to export, for example, only RNA sequencing data measured at the time point 9 hours, I will drag and drop the data node 9 hours under the RNA sequencing data category here, and you can see that it appears here. And if I check the box and export the data out, the exported file will include only the mRNA sequencing data measured at the time point 9 hours. I could do the same for low-dimensional data. So if I want to export only some particular clinical variables, I can do it by dragging and dropping the variable under the appropriate data category. So that's it for the demo. I think it was pretty quick. I hope it was clear and interesting to you. Thank you.